In this video, I'm going to teach you about the product rule. This is another rule to add to your list of things to memorize. If you want to take the derivative of a function times a function, basically you'll take the derivative of the first times the second plus the first times the derivative of the second. Focus for a second on what this is not. You cannot simply take the derivative of each function and then multiply that. You have to use this whole rule. Let me show you how it works. So for example 1, we're going to find the derivative of function h, which equals 3x minus 2x squared times 5 plus 4x. So for this example, if you want to sort of match it up with the product rule, I'm going to think of this first part as f of x, and I'm going to think of the second part as g of x. So if I want to find the derivative of h, according to the product rule, I'm going to take the derivative of the first part. So for now, I'm just going to indicate that I'm taking the derivative by putting d dx in front of it. So this means I'm going to do the derivative of the first part times the second part, which you leave alone. All right, now I'm going to add. Now I write the first part left alone times the derivative of the second part. So here comes that d dx again to indicate that I'm going to do the derivative of the second part. All right, so basically follow the d dx, follow the derivative, because that's the part we're going to do next. So if I want to have h prime, so first I'm going to do the derivative of 3x minus 2x squared. Remember that when you do the derivative of a polynomial, you can do each term separately. So first I do the derivative of 3x, which is simply 3. Then I do the derivative of negative 2x squared. When you do the derivative using the power rule, I'm going to take this exponent of 2. I'm going to end up multiplying it by the negative 2. So that's going to give me negative 4. And then I reduce the power by 1. So then it'll just be x. Now, I didn't do anything with the second part, so for now I'm just going to leave this as 5 plus 4x. I did not do anything with this part. There's no d dx, so I'm just going to leave this as 3x minus 2x squared. All right, now the d dx tells me to do the derivative of this part. The derivative of a constant is 0, so I will write nothing. The derivative of 4x is just going to be 4. So I'm just going to end up with 4. So now I've done the calculus part. The rest is just pre-calculus. We're just distributing and simplifying. So my h prime is going to be, so let's go ahead and do the double distributive property on this part. So I'm looking at this 3 and I'm going to distribute that twice, for example. So that's going to give me 3 times 5 is 15, and then 3 times 4x is 12x, and then now I'm distributing the negative 4 everywhere. So negative 4x times 5 is negative 20x, and then negative 4x times positive 4x is negative 16x squared. So now I have this part where I'm just doing the distributive property. Even though I'm kind of doing it from the right, that doesn't matter. So I'm going to end up with 12x minus 8x squared. So now I'm just scanning through looking for any like terms that I might see. So h prime of x is going to equal, I see, let's start with the quadratic terms, the x squared terms. So I have negative 16 and negative 8. If I put that together, that's going to make negative 24 x squared. Now let's move on to the x terms. I see negative 20 and 12. So that's going to be negative 8x. Oh wait, there's another x term. Okay, so 12 and 12 would be 24. Minus 20 is positive 4. So we're going to have positive 4x. And now the constant term is 15 is the only one. So plus 15. So that's it. This should be the derivative of function h using the product rule. Notice on this particular example, we had a choice. We didn't really have to do the product rule. We could have FOILed this out first and then taken the derivative. Maybe I'll show you that real quick. So here's how I could have done example 1 without using the product rule at all. So I could just rewrite h of x by multiplying this out. So I'm doing my double distributive property right at the beginning. 3x times 5 is 15x, and 3x times 4x is 12x squared. And then I'm distributing right here. So negative 2x squared times 5 is negative 10x squared. And negative 2x squared times 4x is going to be negative 8x cubed. All right, so I'm going to rewrite this in descending exponential order and combine like terms. So the highest power is the third power. So I have negative 8x to the third power. And then I have two quadratic terms. So 12x squared minus 10x squared is positive 2x squared. And then I have my 15x is the linear term. All right, so this is a simpler form of h of x, but in this polynomial form, it will be very easy to take the derivative because I can just do the derivative of each term separately. So because of the power rule, I can take this 3 and then multiply it by the negative 8. That's going to make negative 24. And then we reduce the exponent by 1, so it'll be negative 24x squared. In the same way, I'm going to take this 2 and multiply it by the 2 in the front, and that's going to become a 4. And then when we reduce this by 1, it'll be x to the first power, which I don't need to write. And if you take the derivative of a constant times a variable, it is simply going to be the constant. All right, so here we have the derivative of function h, and we did not use the product rule. But if you compare to what we got when we did do the product rule, you see it's the exact same thing. All right, example 2. Let's find the derivative of y equals 3x squared times sine x. We're definitely going to use the product rule. So let's look at this as two functions that are being multiplied together. The first function is 3x squared, and we'll look at the second function as being sine x. So I'm going to sort of color coordinate this so you can follow what I'm doing. So y prime should equal. Now, the derivative sort of comes through, and we wind up taking the derivative of each one of these functions one at a time. So the first time through, we take the derivative of the first function. So I'm going to have my d dx of 3x squared. And then the second function right now just stays the same. So we'll have times sine x. And then we add. Now the second time through, the first function gets left alone. So we're going to have our 3x squared left alone. But we will multiply by the derivative of the second function. So just follow the ddx, because that's what we're going to do on the next step. We're just going to take the derivative everywhere there is a ddx. So y prime should equal the derivative of 3x squared. So it's time for the power rule, which tells me that I can take the 2, multiply it times the 3, and I will get the 6. And then I reduce the power by 1, so it's just 6x. The sign x unchanged. We're just doing the ddx parts right now, so we're just going to leave that alone. And then we have the plus. And right now the 3x squared is unchanged. There's no ddx. So we've learned that the derivative of sine is cosine. So we will simply have cosine x right now. So that is it for the calculus. Now we're just going to simplify this down a tiny bit. Actually, there isn't much we can do to simplify this down. I noticed that there is a GCF. There's a common factor of 3x. So I can take the 3x out front, but that's really all we can do. If I take the 3x out front, then we're going to be left with 2 sine x plus x times the cosine of x. And that's as far as it goes. That's the end of example 2. Here's one more example. Let's find the derivative of y equals 2x cosine x minus 2 sine x. So we can look at this as having 2 terms. We have the first term, and then we have the second term. Because of the sum and difference rule, we know that we can find the derivative of y by taking the derivative of each one of these terms separately. So in other words, the derivative of the overall function will be the derivative of the first part minus the derivative of the second part. So notice how I use these ddx's to organize my work. It tells me what I'm doing, so all I have to do is just keep following the ddx's and take the derivative wherever those show up, and I won't get lost in my work. So now as I go to simplify this, I need to take the derivative of this first part. But yes, you guessed it, we are looking at the product rule. We can look at this as 2x times cosine x. So this is the derivative of a product. So let's use the product rule. Remember that the product rule says we're going to take the derivative of each one of these one at a time. So we're going to take the derivative of 2x first. And then for now, we're going to leave the cosine x alone because we're just taking the derivative of one at a time. And then we're going to add, this time we're going to take the derivative of the cosine part. So we're going to leave the 2x alone. And we're going to do the derivative of the cosine part. All right, so everything I just wrote so far, that was the product rule. Then we have the other part, the minus ddx of 2 sine x. So let's go ahead and do something with that. So remember, when there's a constant, we can just leave the constant in the front and then just do the derivative of the inner part. So that's what I'm going to do. All right, so now all we have to do is go back through and do all the derivatives, all the ddx's. So I have y prime equals, well, the derivative of 2x is just going to be 2. And so I'll have 2, and then the cosine x, there's no ddx, nothing's happening to it, so I just brought it down. Plus, and then I have the 2x, there's no ddx, so I'm just going to bring down my 2x. Now I left this ddx here to remind me that I need to do the derivative of the cosine. And this is just a rule that we memorized. The derivative of cosine is negative sine. So we will have negative sine x right now. I'm putting this in parentheses so it doesn't look like I'm subtracting. I want to make it clear that I'm multiplying times negative sine x. And then that brings me to this part. So I'm keeping the constant. And again, just we memorized that the derivative of sine is cosine. So I'm simply going to have cosine x right now. So now this is the derivative. I'm just going to look through and see if there's anything I can simplify. And what I notice is we have a 2 cosine x and a negative 2 cosine x. So clearly those are going to cancel each other out, and that's just going to leave this part. So that's why the final answer will be y prime is equal to negative 2x sine x. All right, a positive times a negative is a negative, so I went ahead and put the negative in the front.